if you ever see this, right, this is kind of like the rubric and the guidelines that we'll be following. It's called the SWABATs. The students will be able to. Good timing. So now the idea is that we've talked about this one-to-many relationship. I've alluded to this more advanced relationship called many-to-many. So we'll kind of see how that works. We're going to try keeping groups of data related to the classes in the class. And then ultimately, like, if it's a class, class variable, class methods, instance, instance variable, instance methods. All right. We talked a lot about single source of truth. And then ultimately, like, kind of like how it can go wrong and how it can be confusing. But now, as we implement a more complicated relationship, I'm going to start changing things. And you'll see that if it references, if I make one change one place, it sort of takes place everywhere. Cool. All right. So in your one-to-many, we talked about like a simple relationship like books to author. Right? And the author has many books, and each one of these books belongs to an author. But now we want to talk about a many-to-many relationship. So many-to-many relationship is probably best explained with some examples. And that is obviously projects and backers. And that is a project can have many backers, right? And many backers can back many projects. Yeah? All right. Maybe that one's not great because you're sick and tired of it and you didn't like the lab, but what about regular real life examples? Because like that's what code is, right? Every single time in lecture I'm talking about it, it's like it mimics real life so we can solve real world problems. So parents can have many children, and then ultimately children can have many parents, right? Kind of? Yeah. It takes a village, yes, very good. But something a little bit more practical, specific to New York City, is that like a city bike, right? You have this one city bike. That one city bike can have many riders, right? And each one of these city bikes can what? I'm sorry, all right, a city bike can have many riders, and a rider can ride many city bikes. Like you're not, like you don't own that one bike, right? Whenever you show up, odds are you've gotten somebody else's like fart seat, and it's like a different bike. You know what I'm saying? Does that make sense? It will make more sense if you start to draw it out. But like think about it, like any sport, right? You're like a player, like a baller, and you can play in a lot of different games, and each one of these games can have a lot of different players in them. And so that's like a many-to-many relationship. This one right here is out of control. So the current mod 3, like usually I poll the audience and I'm like, hey, can you think of some other examples? And they're like, they just saw like it. And they're like, clowns can scare many children, and a child can be scared by many clowns. So I was like, yeah, no, that works. But like even yesterday, in the one-to-many relationship, like I started off with like some stupid stuff. I was like, a sick person can have many diarrheas. And then each one of those like bathroom incidences like belong to a person. Anyways, it models real life. And so, yeah, without looking ahead, right? Obviously, there's a fun example in there. But can anyone think of like other many-to-many relationships? It could be as silly as you want.
Cops and paints.
What? Cops and donuts? Right. So like a cop can eat many donuts, and each one of those donuts can be eaten by many cops. Well, you'd have to split the donut though. You know, that's true. True that. Right. That's a good one. Huh? Yes, doctors and patients. So let's like, all right. So let's just not like bash on blue over here. Let's just put like person, right? And donuts. And then you have old doctors and patients. Anything else? Any other examples you guys want to work on? The sillier it is, the better. Or it could be real. I don't know.
Publishers and clients.
Publishers and clients. Talk to me about that relationship.
So a publisher can have many clients, and clients can be published by different publishers.
Okay. Yeah. Yesterday I talked about like gyms and lifters, right? Like as a lifter, I can go to many gyms, and each one of these gyms can have many lifters that go to them. But is there anything else you guys want? Is there any app that you guys want to build? Well, that exists, but yeah, like group messaging apps, sure. Nice.
I was gonna say coffee mugs
Coffee mugs and us, yeah, right? So like mugs and drinkers. All right, that's like a real world example. So like, let's think about this. So this is like a site called Awesome Web App, and it allows you to just like have like a silly, like little whiteboard. And I use this instead of like drawing on the whiteboard so that it persists inside the recording. So stop seeing this ad. I've seen this ad multiple times. Okay, great. So ad close by Google. It's still there. All right. So like I personally like this like squirrels and nests example because I'm silly. I learned this example like 4 or 5 years ago, and I was like, this is delightful. So if like there's nothing else you want to build, I'm just gonna default to this because it's silly. Huh? Well, let's talk about this relationship, right? So I'm just gonna draw this out here. You have a squirrel, right? And we talked about nests. So where do the nests live? Inside trees, right? So I'm just gonna draw this other model. Right now we're doing domain modeling. And so what do we have here? I'm gonna try to draw this. Everything looks like a Christmas tree to me. Nobody. This is on a touchpad, by the way. Nobody's impressed. All right, tough crowd. So we talked about this many-to-many relationship, right? So you have the. I'm not gonna draw a squirrel. This is just S for squirrel. So a squirrel, right, can kind of like have. They're like inside a lot of these trees, right? So this relationship between squirrel and tree is like a one-to-many, right? Now, you're this giant oak tree, and you've got like hundreds of branches. You've got branches to spare. The idea is that like a lot of different squirrels can kind of like live in your tree, so to speak. So the relationship between tree and squirrel, I would say this way, is also like this sort of one-to-many. One tree can have many squirrels. But how do sort of the squirrels and the trees know each other? Think about it like this. I'm just gonna zoom out a little bit. I've got squirrel 1, I've got squirrel 2, boop, and I've got squirrel 3. And then I'm not gonna draw them, but I've got a tree here. This is like a maple. This is like a strong, powerful oak. And this is like, this is like a pine. This is a coniferous. I don't know. I'm not good with like apple tree. I don't know. I'm just defaulting here. So this concept is that like if a squirrel can have many trees and trees can kind of like have a lot of squirrels, how do they know each other? Does this one squirrel, like in theory, have a relationship with sort of like every single tree? Like just think about like the park, right? You're like just spotted a squirrel. Does this squirrel care about or even know every single tree in the park? No, it only really knows certain trees. And it only knows certain trees if it has a nest in it. So back to this domain modeling, right? We can kind of like think of this idea, there's another class in here that exists. So I'm just gonna draw N for nest. And so now we have to talk about those relationships. What's sort of the relationship between a squirrel and a nest? What is the relationship between a squirrel and a nest? Squirrel blank 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 nest. Squirrel has many nests, right? So I'm just gonna draw these lines here. And then each one of these nests, blank blank squirrel. Right, like each one of these nests belong to a squirrel. So if I were to draw it, it's sort of like, almost like this belongs to a relationship. Now, we have to finish out the domain modeling, and that is what's the relationship between this tree and this nest? Right, this tree has many nests, right? We kind of talked about that. But what about each one of these nests? Right, the nest can only really belong to one tree. It doesn't like split in half and then mitosis to like other trees. It's like one nest is in like sort of one tree. So if you break this down, you have this many-to-many relationship. And then in the many-to-many relationship, you have a one-to-many here, and then you have a one-to-many here. So let's see how this kind of works out in real life. Now I wish I could, let me just scroll here. So we're thinking through, right? This squirrel, right? You have maple, oak, pine, and apple. If squirrel 1 has a nest inside the maple, right? So we're just going to put like S1 here, and then we're going to put nest. And then it also has a nest here, and it also has a nest here. But it doesn't have a nest in this apple tree. For whatever reason, apple scares the squirrel. I'm just like, no, I'm good. So boom, boom, and boom. What sort of like relationship, like just looking at the model there, do you think is necessary between the squirrel and the tree? What must exist? Well, I'm talking about like what must exist. If I'm talking about a squirrel as it relates to a tree, right? What must exist? It must have a nest, right? And so this is very abstract, but even then, let's think about like a more real world example. We kind of talked about patient. Okay, that was bad, sorry. And then doctor, so I'm just gonna put this like RX because it's cool. Now, we talk about the relationship between them, and that is a patient can kind of like have many doctors, right? This doctor didn't go to medical school, pay $400,000 or $500,000 to see like one patient for the rest of their life, right? That'd be crazy. So patient has many doctors, and then this doctor can ultimately see many patients. Now, I'm kind of looking at a little bit of a pattern here, but the idea is that like I have this one-to-many. How does a patient know a doctor? Do you know every doctor that's in New York City? All right, you only know the doctor if you've seen them. So there must be some sort of like appointment. That's the only way you know a doctor, right? So if I drop this like other model, more domain modeling. So I'm gonna put appointment. What's the relationship between appointment and person? So like if a person blank blank appointment, how would you describe this? Right, a person has many appointments, right? Like, you're not gonna go to the dentist for like all your medical problems, right? You're gonna have like a lot of different doctors and ultimately a lot of different appointments. So that's sort of the relationship. Like a person has many appointments, but what about the appointment itself? Can the appointment sort of belong to many people or it belongs to one person? Right, so an appointment belongs to a patient. So far, so good. But what about like this doctor and this appointment? What's the relationship between a doctor and an appointment? Like you're looking at the doctor's calendar and you see like one large appointment from today until like next year. Like, no, that's crazy, right? A doctor can have many appointments, and each one of those appointments belongs to the doctor, right? So look, you have this many to many here, and then you also have this like one to many, and this one to many. And again, the patient will only know the doctor through the appointment. So like in the real world scenario, we've got like 500 doctors here. If you've only seen 4 of them, it's probably because you had an appointment with 4 of those doctors. And so that's sort of what the relationship entails. So far, so good, just like conceptually. But now it's like, okay, how do we code this out? That's kind of weird. So let's do it. If you guys want to build patients and doctors, or squirrels, nests, and trees? All right, looks like we're on the fence here. So patient, doctor, okay, and then squirrels, nest, trees. Okay. Okay. You ever seen that meme? It's like, I love democracy. We will build patients and doctors. All right, cool. So let's do that. Boop, boop, boop. All right, we'll just kidding. Just kidding. So let's talk about our domain then, right? And ultimately, we'll have to build these models and these classes. So you'll see I'm starting to just collect a lot of these things here. So let's do it. If I were to kind of think through in terms of like patient, doctor, and appointment, which one should I build first? Well, of these 3, right? Should I build patient, appointment, or doctor? Okay, we can start with patient, right? Does it matter if I start with patient or doctor?
No.
Does it matter if I start with appointment?
Yeah.
Why?
Yeah, which one?
You'd have to really know where you're going.
Right. The idea is that this appointment can't really exist unless the patient and the doctor already exist. This is like joining them, right? This is like connecting them. So let's build patient first. Cool. Okay. Boop. Great. Little class action, patient, and little end patient class. Cool. So what do I need here? Great. Boop. So what are the attributes of this patient? Wow, very good. Sure you didn't want to go with breed? Just kidding. That's not necessary, right? Sure, age, anything else? Huh? Okay, gender, sex, sure. Okay. Huh? Insurance, that's super important. You're right. Like, can they pay? Boolean, right? Sure. Sure, insurance. That's super important in this model. Well, if they're a patient, I'm assuming they're sick. You're right. Could be. All right, let's just leave it at this, only because realistically it becomes very, very wild when you have to like make a bunch of them. So this is just good enough. What else do we kind of need? We probably need those getter-setter methods, right? We also need something else. Oof, my good friend. Cool. Let's do this. And then we need to figure out all of these attributes. What are readers, what are writers, and what are accessors? So reader, okay, name, age, anything else? Gender, oh yeah, you're right, okay, sure. RW, gender, and ultimately insurance. Cool, how are we feeling? Right, so far this model looks like it's kind of like built out in terms of like its accessibility. And then the domain we're working with is sort of like we're trying to build this like doctor-patient relationship. And then the domain modeling, we talked about the one-to-many and the many-to-many and how they all connect. So I know I went over those definitions yesterday, but like as you start to use the words, see the examples, it should start to make just a little bit more sense. Yeah? All right, let's test. Bloop, bloop, bloop. All right, so let's run the patient. And let's see, does the patient exist? Let's make a new one. And what were the attributes? Name, age, gender, insurance. So does anyone want to be a patient? Okay, very good. Age is a number. Forever young. I wanna be. Huh? Wow, Debbie Downer. Okay, I guess male, and then insurance. True, I've got insurance. Thank good. All right, great. Cool, so it works. And then I should be able to at least read or write some of those attributes. So I'm just gonna put Evans equals to that patient. And then if I put Evans dot age, so things look like they're working. Cool. All right, so great. This patient model seems to be so far so good. Let's build out the other one. And that is the doctor. So, Great, a little bit of this, a little bit of this. Great, and then what sort of attributes do we want here? They have a name, age. Sure. I don't want all of the, let's just put specialty. See, now you're on my page, and that is like, all right, cool. Cool. So you see that when you have to make that seed data, it gets wild. All right, cool, just name and specialty. What about these? Okay, good deal. So which one are read or write or read and write? No? Can they?
If somebody said, you go back to school.
Like all of you, back to school, right?
You don't go back.
Okay, great. So we'll go degree as a reader, and then specialty. That can change, right? Cool. Speciality. Great. All right. We should probably test this just at least for syntax errors. So let's run the doctor class. And then we'll test boop, boop, boop. Doogie Howser? I don't even know who that is. Doogie Howser? Is that about right? Just lie to me. Yeah, sure. This sounds right.
I said you were old.
Ah, been waiting to say this for a long time. I guess I'm not. All right. Speciality, right? What is Doogie Howser? Do you know who he is? Sure. A traveling doctor? Sure. Traveling. I don't know. And then what is Doogie's degree? Oh wow, that was very clear. Medical doctor. Great. Okay. I think that's enough testing for this sort of model. And let's get right into it. The idea is that like ultimately at some point we'll have to create this relationship between doctor and patient. So then we'll have to create that join table, that connecting sort of model. And that is going to be through the appointment. Boop, 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 boop. Great. And so what are the attributes of the appointment? Wow. Yes to everything. It's hard to hear, but I love it. So the idea is that for those that like weren't ecstatic, this appointment, the appointment only exists to connect the patient and the doctor. So the details of this appointment must include the patient and the doctor, 100%, at a bare minimum. So let's put patient, oh, dang it, and then doctor. Cool. Sometimes, right, the join table will have additional attributes, and that only makes sense based on the domain and the app that you're building. So the appointment naturally, as some of you have sort of alluded to, and that is like there's some sort of like time, right? Like what time is this happening? We don't want to get too complicated in terms of like adding dates and stuff. Let's just kind of keep this simple. The point of this lecture is about the relationships. Naturally, you want date and then time and some other categories. But what I want to talk about before we move forward is sometimes this connecting table doesn't have like an easily identifiable name. So let's think about some other many-to-many relationships. Like, for example, boop, 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 right? If, however, you're talking about like recipes, right? So let's just do this. We got a recipe here, right? And the many-to-many relationship here is like ingredients. Recipes have a lot of ingredients, and each one of these ingredients can be in a lot of different recipes, like salt, for example. Popular ingredient in a lot of different recipes. And so here, recipe to ingredient is what? Yeah, it's like a one-to-many. But then what about this ingredient to recipe, like we just talked about? Yeah, so now we can kind of see that there's a relationship between them. But is every single ingredient in every single recipe?
No.
That'd be crazy. My kitchen's too small for that. And so sometimes like salt is in everything, right? But that's the exception. So now we know that there has to be some sort of like join. If the join like model table, whatever this is, doesn't have like a sexy name, kind of like patient, doctor, like appointment, that name makes sense. The convention is you just smash the two bottles together. So this connecting table is the recipe ingredients sort of model. But what's the relationship between recipe and like the recipe ingredient? Like a recipe has many recipe ingredients, right? Like if I'm trying to make chicken pot pie, I'm gonna need more than chicken, right? I don't know if I'm gonna eat that, but yes, I'll need a pot, right? And then this recipe ingredient, this particular one, belongs to the recipe. In the same way that this ingredient inside the recipe ingredient, there can be many recipe ingredients. And then each one of these sort of like belongs to an ingredient. But you can already see sort of like this pattern. Whenever you have a many to many, you'll need this join. Cool? All right.
So you do need the third joint always.
If it's a many to many, you'll have to. Otherwise, what you're saying is that if a recipe has many ingredients, by default, without this, it kind of infers that every single ingredient is in every single recipe and vice versa, which is not true, right? So is there undo? Ooh, nice. So yes.
Is that why the Kickstarter was so frustrating because it didn't have that join?
That's exactly right. Kickstarter is frustrating because what's the join table between them?
Okay.
Nothing. You have to duplicate the data. And so, great. So we got the appointment. We got it all squared away. We have the patient and we have the doctor. So now let's kind of start establishing relationships. And what I mean by relationships is that a patient should be able to reference the doctor somehow and vice versa. That's sort of the relationship between them. So as a patient, at some point, I will need to know like all of the patients, all the doctors, and ultimately all the appointments. So let's sort of build that functionality. So as a patient, how can I get all the patients? Right, I'll like dump it into like a class variable. So we can have like, again, just this sort of looks like a pattern, but you can have like all patients if you wanted to. I'm just gonna use all. And then whenever we create one, I'm just going to sort of push it into this collection. And now this being a class variable, I need the class getter method, right? So I've built these getter methods. I've built the getter and setter methods for the instance variables, but now I'll have to build the getter method for the class. So can I just do this? Is that good? Well, what is this right now? It's instance method. So by referencing sort of like the self or patient.all, that's kind of like giving me that class method. And by kind of, I mean it's giving me the class method. I didn't mean to be ambiguous about it. Great. Boop. 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 And then we want to shovel in self. Just kidding. And this is just going to give us access to everything.
So any reason you don't put like the class method in our accessors?
Say again over?
You know how we have attribute accessor?
Uh-huh.
We can't do the shortcut macro for class variable?
That is correct. The macros only exist for the instances. So, did we test appointment? No. What would we run into if we tested it? Not yet. Can't read them, right? I can only catch this quickly because I've been doing it for a long time, but you should be testing along the way. So here you'll see that you like can't actually access them. So we'll need the reader for patient. Oops, whoa, just kidding. I got wild quick. All right, doctor. And then what about time? Should time be read only? Right, probably time. Cool. All right, any questions on literally just setting up all the models, the domain, and then the domain modeling?
Why would you have it as only reader the patient doctor? Because for the appointment to be set, right? Because that's what appointment does, it sets the patient and doctor up together. I would think it would be accessible.
I mean, yeah, we could do that if you want to.
No, I'm just saying, does that make sense? Because
It's app dependent. What do you want your app to do, right? And so, in the words of a very famous 90s cartoon character, the power is yours.
yes.
Thank you. Did anyone know?
Captain.
This is Captain Planet, yeah. All right, so,
That's it. I didn't know what that was.
all right, very good, cool. Thank you, thank you. All right, cool. I'm just gonna get rid of these pries because if I have the pry, it's gonna pause every single time I try to run any of these things. Now I have all three, and does the patient, the doctor, and the appointment, the files and the code have access to each other? No. Now, some of you have like built sort of like this combo file like in your labs, and that's cool and that's great to test. But what spec will do is it will pull in all the files for you. And so you don't actually have to build it if you have the specs. Now, when we get to week 3, you're gonna learn how to build RSpec, how to write tests, and kind of like how to think through all the tests, which is like really cool. We'll talk about you'll talk about the Power Rangers at that point, which is like really funny. And the idea is that if your tests are really good, then you should just be able to run the tests and then like test your code that way. But here, because like I haven't really explained RSpec or like how to write the tests, that's why we're using the pry. That's where we're stepping through every single method, and we'll have to build this combo file so that they have access to each other. Cool? All right, so instead of like a combo file, typically what you'll see is you'll see something called like a run file. And that's going to essentially be the one that brings in all the files that you need, so everything's in scope, and this is what runs your code. That's why it's called run. So inside this, okay, I have a run.rb. Okay, that's right. Yeah, look at this. Oh, Krusty. I don't know who Ronald was. Oh, Ronald McDonald? That's what they were talking about. Bozo. They put teeth as an attribute. I thought that, I mean, that class is hilarious. There's Penny there. All right, anyways. So naturally, we need access to all the files. So instead of clown, we have the doctor, we have patient, and then we have appointment. That was too many of those. Cool. So the first thing I'm going to do is I'm just going to like run this to make sure I didn't put any typos, my syntax is okay, and then I have access to all those classes. So boop, let me just save. Boop, 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 boop. Cool. Nobody? All right.
How would you do that?
I'll show you in a second. So let's check patient. Right, you have appointment, and you have the doctor. Yeah, so they all exist. So that's like I'm just pulling them all into scope. Sometimes what you'll want is you want to like move your screen around, and you want to do like this. There is something that you can download. It's called Spectacle. It's totally free. If you want to spend the one whole dollar, there's an app called Magnet, which I think is like just slightly better. And you can create like little shortcuts on like literally like adjusting your screen very quickly. What you'll start to see is as you progress, whenever you take your hands away from the keyboard just to like touch the mouse or touch the keyboard, you lose time. It seems like such a micro fraction of like a second, but you lose it because of how fast you can think. When you're really like thinking, you don't want to be like pulling your hand off the keyboard, because then the more you can type, the faster you can type, the more code you can kind of run through, and that way you don't slow down your own thought process. So you'll see me like literally slowly, I will, sometimes on certain lectures I'll bring a mouse in, otherwise I'll use too many shortcuts and it's very hard to follow. But learn the shortcuts because they will help you with development, right? All right, cool, that was like a quick aside. So now we're talking about like doctor, patient, and appointment. You've kind of set up the models, we've tested them, and now we're gonna start building out like some of these deliverables. So you might see something like, great, a doctor, right, should know all their patients. Right, that's like a normal sort of like feature request, right? Like if I'm building out this sort of like, what is it called? Like EMR, like electronic medical record, and I'm a doctor, I come in and I'm like, great, what are all my appointments, right? Or like, can you show me all the patients that I've seen? I want to be able to reference them somehow. So that's like a normal feature request. Then you'll have some deliverable like a patient, right, should see all their doctors, like a normal thing. And then ultimately something like maybe like a patient like should see if they have seen, right, I don't know, podiatrist, right? We have specialty in there. So there's just like pretty simple features. And so right now, the idea is that you kind of know how to build them, and that's okay. In development, oftentimes you'll know how to do, if you're lucky, 70 or 80% of the feature when you first get it. That's the beauty about this job. Like, there's so much that you're like solving kind of like every day, and you're like pretty stimulated, and that's cool. Most of the time you'll know like 30 or 40%, but it's about breaking down that big problem into small little chunks. So before we get started, we have a couple things we could do. It's 11:50. I could push to lunch and then break, or we can call it here and then pick up